What is Helicobacter pylori? H. pylori is a bacteria that lives in the stomach of humans, which is odd because the stomach is an extremely acidic environment. You wouldn't expect to find much growing there, which makes H. pylori all the more remarkable for having evolved enough traits to allow it to exist in the extreme environments of the human stomach. The relationship between H. pylori and humans, though, is not a happy one. H. pylori infection in humans is strongly correlated with stomach ulcers and gastric cancer. So while H. pylori gets a home to live in and an organism to constantly supply it with nutrients, humans suffer from their presence. H. pylori was first described in the 1980s. The work surrounding its discovery eventually led to the 2005 Nobel Prize in Medicine. However, H. pylori did not just begin to infect humans in the 80s. Humans have been carrying around H. pylori in their guts since the dawn of modern humans. Humans began to first develop in the Horn of Africa. They then migrated out of Africa and spread from there into Asia and Europe. Scientists collected samples of H. pylori from all over this area and sequenced them genetically. They used this data to determine how different strains were related to each other. Data like this can be used to make a phylogenetic tree. What was so remarkable is strains in Europe and Asia developed from the strains in the Middle East. Likewise, the strains in the Middle East seem to develop from the strains found in Africa. So it appears H. pylori spread throughout the globe, mirroring the exact pattern our ancestors used. We can infer that even our ancient ancestors were battling this hitchhiking bug even as they first moved out of the Horn of Africa. Because H. pylori and humans have been living together for so long, it offers us a chance to examine how these two species have co-evolved. Humans have not taken lightly to these pests living inside of them. Likewise, H. pylori has had to develop new weapons to ensure its survival within the human stomach. This relates to an evolutionary theory called the Red Queen hypothesis. The name comes from Lewis Carroll's Through the Looking Glass, where the Red Queen states to Alice, "It takes all the running you can do to keep in the same place." Evolutionarily, what this means is H. pylori and humans are constantly in a race against each other. H. pylori develops new ways to colonize and protect itself in the stomach, and find new ways to prevent H. pylori from taking hold, but neither is able to completely overtake the other. You can think of it as a giant arms race, where one side is always trying to one-up the other side, and both develop new weapons, but completely outsmart the other. For instance, humans have developed a mechanism to protect infants from receiving H. pylori from the mothers. Infected mothers can send antibodies against H. pylori through the umbilical cord to the baby. These adaptations do not just appear randomly. The constant battle between humans and bacteria creates a selective environment for new adaptations, which allows them to overcome the other. A common misconception is that this process takes thousands of years, where in fact the process can be remarkably quick. In one recent study, they tracked genetic change in H. pylori after it infected a patient. The rate of adaptation was so quick it evolved new tools at its disposal specifically to that host. Another way we see rapid change in H. pylori is with a common theme amongst pathogenic bacteria: antibiotic resistance. Although not an innate aspect of the evolutionary war between humans and H. pylori, antibiotics provide an extremely strong selective pressure. If just one bacteria, such as this blue one, develops a mutation that gives it an advantage over the other bacteria and that it cannot be killed by the antibiotics, then this will be the genes that pass on through generations, and soon you will see entire populations of bacteria that have become resistant to this antibiotic. So what did we learn? We learned about phylogenetics and its use to determine the evolutionary history of a species. We learned how natural selection shapes species and drives evolution. We learned that migration and gene flow can provide new genetic variation that can result in different adaptations and characteristics in species. We learned that evolution is an important thing to keep in mind when talking about medicine. We learned that genomes evolve and change as they acquire both good and bad mutations. And we learned about species interactions in which two different species shape each other's evolution, in this case, humans and H. pylori. We have seen that evolution does not need millions of years to happen, and can in fact happen quite rapidly. We learned that humans are still evolving and adapting even today. We also learned that just because something is evolving does not mean that it is getting better. Life is constantly trying to change just to stay in the same spot. We also learned that evolution does not mean that everything evolves by random chance. The selection pressures that both humans and H. pylori put on each other are examples of how this is not just random chance.